Hello, ladies, and happy Sunday. Well, it is Sunday now, but when you're listening to this, it's probably Monday or maybe another day of the week. But it was a beautiful weekend. I'm going to miss the sunshine. Apparently, it's going to be 11 degrees tomorrow, and which could be today if you're listening to this on Monday. But do stay warm, and if it's sunny, go and get some sunshine because I think sunshine always makes us feel a little bit happier. All right, let's move on. So we've only got 3 more questions to do. I'm not doing I think it's the enrichment section of 5G, but if you want to do it, go ahead and I'm more than happy to give you some help. I had a look at the questions. They're not, well, the one I looked at wasn't too difficult, but have a go and I'm always here to help you. But I'm just going to finish off these videos for 5G doing 12, 13, and 14. All right, so question 12. The sum of the first n positive integers is given by half n times n plus 1. So just before we move on, remember an integer is just a fancy name for a whole number. We're looking at positive, so anything greater than 0. All right, so question 8. Find the sum of the first 10 positive integers, i.e. use n equals 10. So I've got this bit here, the sum, so it's added all together. So we're only, let me just write A. We're only looking at the first 10. So this is a straight substitution question. So n equals 10. So that means the sum, and that's a funny sign for the first 10 integers is equal to half n plus 1. Now n is equal to 10, so it's a half times 10, 10 plus 1, and we're just going to put that all together. So a half times 10, that's the same as 10 divided by 2, which is 5, and then 10 plus 1 is 11, so our answer is 55. All right, find the value of n in the sum of the first n positive integers. So the same thing, we're just substituting it in. So maybe instead of doing 28 and 90, oh, hold on. Sorry, I didn't read the question properly. This is what you do. You leave things to the last minute, girls. You never leave things to the last minute. So it's 8:30. I should have probably done this a little bit earlier. I didn't read the question properly. Find the value of n. So this time we don't know what n is equal to. Okay, good. I was wondering why they would just get us to do something the same. All right, so write the formula. So we've got half n plus 1. And for B part 1, I'm going to let it equal 28. And then we're just solving for n. So I'm going to do this one, but I'm sure you can, if you can do this one, you'll be fine with the rest. All right, so we've got a half here. Now the inverse of a half, or the opposite of a half, is multiplying it by 2. So whatever we do to one side, we do to the other. So that 2 times a half becomes 1 and disappears. And then 28 times 2 is 56. And then we can expand this and you can see it's going to turn into a quadratic. So n times n is n squared, n times 1 is n. And I'm going to bring that 56 over now. All right, so now I'm going to factorize it. Now, you can always use a quadratic formula if you want, but this one looks like I can find 2 numbers when multiplied give me negative 56, and when added together give me 9. Oh, 9. Oh my gosh, give me n. Why did I say 9? I think because I'm thinking of factor pairs of 56 while I'm thinking. Okay, so our 2 numbers, I always like to do this when I'm doing factorizing. It kind of sets it up. Because this is a negative and this is a positive, one of your numbers is going to be positive and one is going to be a negative. Now your factor pairs, the difference between the numbers is 1. So you've got 8 times 7. Okay, and with 7 being the minus and 8 being the positive, because we've got a positive 1 in front of n. Now at this point, some of you will probably already know that n equals negative 8 and n equals positive 7, but I'm going to separate it using what we call the null factor law. So we just let each bracket equal 0. So if I take away 8 from both sides, n is equal to negative 8. And if I add 7 to both sides, that disappears, n equals 7. Now remember, we're dealing with a number of numbers, integers. Okay, so remember n, if I just go back up here, n positive integers, so n is the number of integers. We can't have a negative number of something, so we only have one solution. So the first 7 numbers add up to, what was that, 28? Can't remember, 28. All right, and you do the same thing for the other 2 parts of question B. So maybe have a go at just one of them because your method is exactly the same. All right, question 13. A ball is thrust vertically upwards from a machine on the ground. The height h meters after t seconds is given by h equals t times 4 minus t. I think I really need to make this bigger. I think some of my problems are because my eyesight is going. All right, I kind of think of this in, if you've ever played tennis and maybe your coach is a bit lazy to hit the ball and you have a ball machine throw the balls to you. So the good thing about quadratics, a typical thing with quadratics or parabolas, the graph of it, is you often get problems that involve a ball because when your ball goes up, it's got to come back down again. So if you think of, this being time and this being your height of your ball, okay, it's always going to go up and then come back down, okay? So you can see h, your height of the ball, and t over time. Okay, so let's have a look at these questions. So we've got a few questions here. This is a typical extended response type question. So you can see here different, you're doing different things with the same equation, but basically your ball's just being thrown up in the air. Okay, so we've got h equals, t is 1.5, so we're going to have 1.5 times 4 minus 1.5. Now, on your CAS calculator, you can obviously, oh no, we wouldn't use solve, but you can use solve on your calculator if you need to, so maybe when we have to solve for t, but this you can easily do by hand. So this is where you need to be able to multiply by decimals. So I'm just going to finish this off. So 4 minus 1.5 is 2.5. Now, if you find it easier, and I'm going to do it over here, I much prefer multiplying fractions. So you can do that if you want. So 1.5 is 3 over 2 and 2.5 is 5 over 2. So remember, you multiply your numerator. So 15 over 4. And then, what is that? 3 3/4, which gives you 3.75. But if you, and you should also know how to multiply decimals. It's funny, when I taught methods a long time ago, I always had to reteach multiplying decimals. So just treat them as 15. And if you want to do long multiplication, you can, times 25. So 5 times 5 is 25. 1 times 5 is 5. And then you got plus 2 is 7, which is 0. 2 times 5 is 10. And 1 times 2 is 2. Plus 1 is 3. So we've got 375, if you didn't know your 15 or 25 times tables. Now, with your decimal place, you look at your question. So how many decimal places do we have each number to? So this first one, 1.5, is to 1 decimal place. The second number is to 1 decimal place also. So altogether, we've got 2 decimal places. So this is 1 and this is 1. So your answer is going to be to 2 decimal places. So that's where we get 3.75. If you want more practice doing multiplication of decimals, please let me know. And I've got a lot of stuff for you, or I can find stuff for you. Okay, question B, find when the ball is at a height of 3 meters. So this is where you could use solve on your calculator, but you shouldn't rely on your calculator. Sorry, I just need to see the formula. So we've got h equals t 4 minus t, and h is going to be 3. Is that right? Just make sure. Okay, so now we're solving for t. So I'm going to expand this bracket now. So we've got t times 4 is 4t, t times t is t minus t squared. And with your quadratic, see how this is a negative t squared? I'm going to put it over to the left-hand side and make that a positive. The 4t also comes over, but that becomes minus 4t. And then we've got the 3 as a positive. Okay, so then we factorize. So this one's an easy one to factorize. Two numbers when multiplied give you 3 and when added give you negative 4. So that's t equals negative 3 and t equals negative 1. So when we solve for that, we get t equals 3, t equals 1. So when you think about your graph, let's say this was 3. There's the line h equals 3. It hits it twice. Okay, it hits it once on the way up and again on the way back. So when the ball hits a height of 3 meters, it hits it at t equals 1 and t equals 4. I mean, this graph isn't to scale, but it just gives you an idea of what it looks like. Not t equals 4, what's it? T equals 3. Sorry about that. I knew as soon as I wrote it, it was wrong. T equals 3. Why are there 2 solutions? Oh, I just answered that question. So 2 solutions because the ball goes up and comes back down. The only time you will have one solution is this bit here, which we call the turning point. Remember, I've often referred to the turning point, but you don't need to know that just yet. Okay. Find that when the ball is at ground level. So at ground level is at h equals 0. I don't know what it wants you to explain. Maybe that it's when h equals 0. So let's let h equal 0. I might do that over here just because I'm running out of room on the page. So we've got 0 equals t, 4 minus t. Now I can, I thought I could skip a bit, but not really. And then we're just solving for t. So you can take, oh, actually, what am I doing? Forget about that step because I can do this here. Either t equals 0 or 4 minus t equals 0. So that means t equals 4. So find when the ball is at ground level. So it's at 0. Probably not the best graph. Maybe I should have started it here. And at 4. Find when the ball is at a height of 4 meters. So we're going to substitute in h equals 4 this time. Sorry, my working out is all over the place. Oh my gosh. Okay, so I'm just using the same equation, but I've just skipped to the expanded part. So we've got t squared minus 4t plus 4 equals 0. So we're going to have t minus 2 equals 0. So that means t is equal to 2. And that is the turning point here. So we're only going to have one solution. And you can see that is halfway between the 2 points where, what is it, h equals 0, okay? And it's also halfway between your 2 points when h equals 3 because your graph is symmetrical. Okay, so there it is there. Why is there only one solution for part E? That's because your ball has gone as high as it can and then it's come back down. Is there a time when the ball is at a height of 5 meters? No, there's not. Now, if we were to do that, we wouldn't be able to get a solution, don't think. I'm just wondering what would happen. Just thinking while I'm doing that, you wouldn't actually get a solution because h can't equal 5. Your highest point is h equals 4. And when you go into methods, you refer to your domain, which is your restrictions on your t. So we would say your t values go from 0 to 4 and including 0 and 4. So that's your domain. And your range are your h values. So that would be from 0 to 4. Okay, let's move on to the last question. So the height, h meters of a golf ball is given by same thing. Okay, so here's your golf ball. Whee! That's the sound a golf ball makes, by the way, if you haven't heard one up close. Where x meters is a horizontal distance from where the ball was hit. So maybe I'll start this one at. Okay, so your horizontal is x meters. Whoops, x. So this time it's the horizontal distance, not the not time. And h is your height. Okay, find the value of x when h equals 0. All right, so I did have to just delete a bit because I was doing it. I was expanding the brackets and then I realized I didn't have to expand the brackets. So if things just looked a bit glitchy then, it's because I just deleted a bit of the video. Okay, so question A, find the values of x when h equals 0. So we've got 0 for h, then we're solving for x. Now, as I said for the previous question, you can use solve on your calculator, but you need to know how to do all this by hand, especially if you're planning on doing methods. A lot of stuff is done by hand. All right, so we're solving for x. Now, at this point here, I can eliminate this negative 0.01x. Now, usually we don't divide by decimals. It's just, I guess, not the done thing, but, you know, basically this 0 divided by negative 0.01, they cancel each other out, and 0 divided by anything is still 0. So we don't have to, you know, turn it into a fraction or anything like that. Okay, so that coefficient, no matter what it was, we could have got rid of it, which is nice. And when I showed you parabolas the other day, okay, so this number here doesn't affect your x-intercepts. It just basically changes your graph, whether it's wide or narrow, okay, not its x-intercepts. All right, so now we're going to have, we can separate this. So we're going to have either x is equal to 0 or x minus 100 equals 0. So that we've got x equals 100. So if I go back to my golf ball, the golf ball was hit here at 0, okay, at the ground, and it landed here at 100 meters. Interpret, oh gosh, I love it how I answer a question and then I read the question and I've already answered it. Interpret your answer from part A. Golf ball was hit here. Goes whee, because remember golf balls make noise, and then ends there at 100. Find how far the ball has traveled horizontally when the height is 1.96 meters. Okay, so, oh, that's weird. So your height is 1.96 and your formula for your equation is that. All right, and now we just got to solve for x. So again, we can divide both sides by negative 0.01. And that cancels. And if this is too difficult to understand, I'm going to deal with that in a sec. Let me just think of the best way to explain this to you. I'll come back in a sec. Let's just tidy up this side. So we've got x squared, x times 100 is minus 100x. I'm just thinking of the easiest way to do this with you. Some people, because you learned this stuff in year 7, so maybe seeing it like this is difficult to understand. We've got a negative here, so I'm going to just put the negative there, and we've got 0.01. We're dividing this by 100th. And when we divide by 100th, so if we do that maybe as a fraction, okay, so don't worry about what's happening on the right-hand side now. We're just worried about this. When we divide by 100th, we're moving our decimal point to the right. Okay, so we're going to have 196, negative 196 equals x squared minus 100x. Now, if you prefer to keep it as a decimal, okay, when you're dealing with decimals, you always divide by a whole number. So at this point, we're dividing by a decimal, so 0.01. So I'm going to change that to 1. And then I have to think about, well, how did I get that to 1? I moved my decimal place 1, 2 spots. So that means I do the same with this one, 1, 2. Okay, this is easy because we're dividing by 1. But if it was 2 or 3, the working out would be the same. Okay, whatever your number is, it's easier to deal with a whole number. So I've made that number 1. With this, how I changed it to 1 is I moved the decimal 2 spots, but whatever I do to my denominator, which is here, I have to do to my numerator, so I had to move that place 2 spots. So effectively what we've got now is 196 divided by 1, which is 196. But if you had a 2 here, you'd change that to a 2, and 196 divided by 2. So decimals will come back and haunt you, but hopefully you're okay with them. If not, make sure you either let me know or your future teacher know if you need some help. Okay. My son is downstairs yelling at his friends playing 2K20. I'm just making sure my negatives are good. Okay, so at this point we've got 196 or negative 196, so 2 numbers that multiply to give us negative 106, and when added together give us negative 100. I'm going to have to pause and just think of what they are. Oh my God, every time I pause, it's pretty much straight away I know what those numbers are. So it's going to be 98 and 2. And I just realised that has to be a positive. So negative 98 and negative 2, so x minus 98, x minus 2 equals 0. So your values of x are going to be 2 and 98. So remember, it's also going to be symmetrical. So if I got, say, 2 and 50, when I kind of draw my dotted line like I did before, the distance from this point and 0 should be the same between this point and 100 because they're symmetrical. If I got not 2 and 98, so let's say I got 2 and 50, I'd know I got something wrong. And also halfway between 0 and 100 is 50, so that's your turning point there. Okay, so you only have one and the corresponding height, which we don't have to do, but you know, it's always nice to know how it works. So this point here, 1.96, which we just found out, and that's at x equals 2 and x equals 98. Okay, so just take your time. As I was working through it, I knew right down the bottom that I'd missed something. Okay, so if something isn't working for you, always check whether you've made an error. Don't assume that it's going to be more complicated than it is. All right, girls, best of luck. See ya.